Hello, everyone. My name is Aklant Kumar Bhowmick, and I'm a postdoctoral fellow at the Department of Astronomy at the University of Virginia. And today I will talk about one of my research projects, the larger objective of which is to unravel the origins of some of the most enigmatic objects to be discovered in our universe, called supermassive black holes. And I do this using the tools of large scale cosmological simulations combined with machine learning based techniques. But let us start by talking about what exactly are these supermassive black holes. So the word supermassive basically implies that these are amazingly massive black holes. Particularly, they can weigh anywhere from a few million to a few tens of billion times the mass of our sun. And it is now very well established that these supermassive black holes exist at the centers of pretty much every massive galaxy in our universe, which basically brings the question of what were their overall cosmic origins. And all of this is absolutely mystifying because the only known robust process with which we can form black holes in our universe in general is through gravitational collapse of stars at the end of their lives. But through this process, one can at best form what we now refer to as stellar mass black holes or ordinary black holes. And their masses would at best be limited by the masses of their progenitor stars from which they formed, and therefore they would be around a few tens of solar masses or so. But now we have these supermassive black holes weighing more than a million solar masses, and these would obviously not have formed in the same way as these stellar mass black holes formed, simply because we don't have stars that are at least a million solar masses. That's just impossible. So, how did these supermassive black holes form? Well, perhaps they were not born already supermassive. Perhaps they started out as much smaller, what we now refer to as seed black holes. And this brings to the key question that guides my research, which is basically what was the nature of the very first seeds of these supermassive black holes? What were their formation mechanisms? And what were their initial masses? And to address this question, I've basically built a new suite of large volume cosmological simulations, which I've named as the Brahma simulations. And one of the key predictions that I make with these simulations is basically of these entities called gravitational waves. These gravitational waves are basically ripples in the very fabric of space and time, which are produced when compact objects such as black holes merge with one another. And these gravitational waves are essentially one of the key observational targets that we anticipate to detect with future facilities such as the Laser Interferometer Space Antenna. And here I'm basically showing predictions from my simulations for the rates at which we anticipate gravitational waves. And these two plots combined together show about 100 lines coming from 100 simulation boxes, each box modeling a distinct scenario for how these black hole seeds may have formed. And you can clearly see a huge diversity of these gravitational wave event rates depending on the seeding model. So this motivates me to take the next step, which is to basically use these predictions from the simulations as training data to ultimately build a simulation based inference pipeline based on machine learning techniques, which can then take the observations of gravitational wave event rates coming with these future facilities, and with this machine learning model, we can constrain the origins of supermassive black holes from these gravitational waves. And with that, thank you very much. Here's my summary slide.